So this is problem 11.1.55, and the problem reads that we have 7 people, 4 women and 3 men. That's not real legible there, but I'll read it to you. So we have 7 people, and there's 4 women and 3 men arrange themselves randomly in 7 consecutive seats in a row, and we want to find the probability that the men will be in 3 adjacent seats. Okay, so what we have is we have 4 women and 3 men, and they are arranging themselves in 7 consecutive seats. Okay, and we want to find the probability that the men will be in 3 adjacent seats. Okay, so there's a couple of levels of counting in this problem, and the first thing is we have to think about the men and how many. We have to count how many different positions they could seat themselves next to each other, all 3 of them, within the 7 seats. So I'm going to draw out 7 slots here, and we're just going to have to think about this. So we could start with the 3 of them being grouped in the first 3 seats. Okay. And then we could, and then you're just going to count this, and they could be grouped starting with, at the second seat, and they're supposed to all be together here. So, and then we could, and you're just going to, for this aspect of counting, you literally just have to, write it in here and count it and see how many there are. So we can start them with the first seat, the second seat, the third seat, and you just continue this. If we start them at the 4th seat, they would be grouped like that, and then the 5th seat would be when 2, 3, 4, 5, would be the last option for them to sit together. So if we count this here, there's actually 1, 2, 3, 4, 5 ways for them to sit next to each other in 7 consecutive seats. So that's one part of it. Okay. The other part that we have to count is how they can be arranged amongst themselves, and then how the women can also be arranged in the seats that they're in. And they're asking us for the probability in this problem. And remember, probability is always your desired outcome over your total outcome. Okay. So our desired outcome here is the number of ways for them to fulfill this. And so there are 5 ways for them to fulfill, all being together in the 7 seats. There's 3 factorial ways for the men to be seated amongst themselves, because there's 3 options, 3 options here to put one of the men there, and then you have 2 left and 1 left. And there are 4 factorial ways to seat the women in the seats that they're going to sit in. Okay, so this is our desired outcome. This counts the number of ways these men can sit together in the 7 consecutive seats. Randomly assign themselves to that. Okay. And then the bottom part of our probability is always the total number of ways that we could seat these people. And since there's 7 people, there's 7 factorial ways that we could seat them. So, we have 7 choices for the first seat, and 6 choices for the second, 5, 4, 3, 2, and 1, which is 7 factorial. Okay. If you simplify this, I believe this is 720 over 5040, which reduces to be, I think it's 1/7. Yeah, reduces to be 1/7. And so that would be it in this problem.